Nope. In this discussion, we're going to talk about our favorite property of limits. There's several useful properties of limits you should read about in the lecture and in your book. But this is our favorite property of limits. We're going to use it a whole lot, so we're going to dedicate a discussion to it. This property says that if you have two functions that are equal to one another, their limits are equal. And that makes sense. But notice this little exception. If the two functions are equal, except possibly when at this one value, okay, then the limit of the two functions is equal. And that's going to be very useful for us. Here's why it's going to be so useful. Let's look at this example here. We're trying to evaluate the limit as x approaches 1 of this function. And so we think, oh, we'll do direct substitution. Well, this function is not continuous at 1. When a function is not continuous at 1, direct substitution doesn't work. And here's why. If we plug in 1 into our denominator, notice we have something squared plus something minus 2. And the something is 1. We're going to plug in 1 for the x. Well, that gives us in our denominator, 1 squared is 1. 1 plus 1, as we've known for a long time, is 2. And 2 minus 2 is 0. And so we have 0 in our denominator, and we have an undefined expression. So, whoa, what do we do? Direct substitution is not working. Oh, this is where we fall in love with this property. Because what we can do, if we're trying to evaluate this limit where direct substitution didn't work, we just noticed that our argument here, x minus 1 divided by the quadratic x squared plus x minus 2, is equal to 1 over x plus 2 as long as x doesn't equal 1. As long as x doesn't equal 1, then this argument is equal to this expression 1 over x plus 2. That's what this says here. This, which was our argument in our limit, is equal to 1 over x plus 2 as long as x doesn't equal 1. Well, if you have two functions that are equal, f and g are equal except at one value, such as 1, then the limits are equal at that as x approaches that one value where they weren't equal. So, our favorite property, if we're trying to find the limit of this function, we can substitute in this other function, 1 over x plus 2. And now direct substitution does work. We get 1 over 1 plus 2, which is equal to 1/3. And we've evaluated the limit. This is equal to 1/3.